Hello everyone, welcome to my YouTube channel again. My name is Andy and I will be making a homework walkthrough videos for section 6.2, volume by cross-sectional slicing, and it's the first way to find the volume of a solid by integration. So in this section, as we first find the volume, and it's like the idea of the volume is like to be rotating by a region. And this section, we just take a slice in the region of like a solid, as like a loaf of like a toast. And there's like a piece of ham, you just cut them into different equal width of intervals and just put them together. For here, it's like to use the shaded region is the region to the cross section area. It's like the width is 4 and the height is a cosine of x. So the function is going to be 4 cosine of x is a function. Interval from 0 to pi over 2. This is the same thing. We are just here 5 is like the interval, not the width. The width, it is square root of x. And the solid here is like the width is like the square root of x, and like the height is square root of x and is x because this is a square. So square root of x times square root of x is x. Well, here like gonna be 2 times x to the square because it's like a solid, a triangle here, but it's a triangle. So it's like the area of a triangle is 1/2 of base times height. So it's the 1/2 x to the squared. Make sure pay attention to the triangle area formula here. Here's going to be fx minus gx to the squared. Is we have an inner radius and an outer radius as we just rotating by the x-axis here, because like in this part of the volume, we are discussing about like volume obtained by rotating a horizontal axis. So outer radius, it is fx. Gx, it is inner radius. How we kind of region between is like fx minus gx, and to the squared. I will discuss this later because this is like a harder problem than we just copy apart. So base of S, the triangular region, just draw those vertices. And it's like lay down triangle here and just try to find a volume. In this case, it's going to be the case 1 is 2 curves and it's rotating about the x-axis. In this case, if the gx is the x-axis, then is just the pi f of x squared to the dx. That's just a volume. For this, you have the interval given here, but now you need to find the curve, the positionality, that which one is above and which one is under. Obviously, put x to a 0, this is gonna be the 4, and this is gonna be, because this curve is like decreasing slope, so those two they're out. And lower bound is y equals to 0. So this one is the region. It's a trapezoid, but we do not compute a trapezoid here. We just use integration. Either way. But because this is a way you can find the volume of trapezoid, like a solid trapezoid, because like you know how to find the volume of a cylinder, of a cone, of a cube, but not this one. So you just need to remember the region formula. It is a top minus bottom. Top minus bottom. You have, and this case one here is like going to be, this case is going to be y equals to 4 minus 1.5x minus 0, and then it's dx from like 0 to 1 is your interval. And then just to draw this like region. Okay, in this case, you need to use the in this case, I will use the dx as x is gonna. I will use the dx as x gonna be 1 over half of y squared. Use dy to integrate because they're easier in terms of y. So we just need to find it's like x equal to 1 over 2y squared and x equal to 2y. Find the intersection and then determine which one is above another. There's two curves. Then we need to use like outer radius and inner radius. So it's like similar to this, but just to change to dy, upper bound and lower bound, just between the curves. So it is this one. So how upper bound is 4, lower bound is 0, and we have integral here. So make sure it is using dy. If it's in dy, it's a variable to integrate. Then the interval should be y value, not x values. This is going to be the same thing, but more variation about the x to c axis. You have to draw the region, and if the axis it is if the axis it is like it is like above under, make sure they change like variation here. And for this one, and it just need to just change like the rotating axis, like the inner radius, because it's a washer. Actually, in this case, axis to what? This is going to be the shell method here. So c minus so this will be case number 2. Use x minus c, then just f minus gx, top and bottom. Then find the volume of this. Find the volume of this solid obtained. Number 6 is R2 about AB. So this is top bottom. This is axis. for tan of x to 3 and 0 here is like the line y equals to 3. So this is the rotating axis, y equals to c axis. And you need to find from just between tangent squared of x and the y equals to 3 from 0 to the intersection. In this case, you need to find when tangent of x intersection. Yeah, about the thing is like y equals to tangent of x and then y equals to 3. It's just a fine interval and just to have, because like it's hard to do with a visualize. So I would make visualize the handwritten guide for this question, but it just use this variation. Just I would send this study guide to the server, so you will know how to just write integral for different kind of a way that is how they're that based on information have here. And for those really hard questions, I'm not go over on this video because like it is hard to just explain them well. So I would make a handwritten guide to this last few questions. And feel free to ask me for anything, and I'm willing to help you guys because I wanted to make your life easier. No, I would discuss number 8. So this is like dy here is like first of all, it's like dy looking like the volume, so we eliminate the first and number 1, number 2 out. Because if you do like this, because if you do like the square root something, it will be like a y4 and a y8. Rotating gonna be because it's dy, so this is gonna be rotating about like the x-axis. So gonna be the third one. I think that's gonna be for this part of homework. So let me know if you have any questions, and have a great day. Thank you guys for listening.